Okay, so using chi-squared, we're going to test whether there is any association between the two variables. So in this case, whether people living in different areas would prefer money to be spent in a different way. The first step is always to state the hypothesis. H0 will always be that there is no association between the variables or that the variables are independent. So in this case, there is no association between area and preferred spend. H1 then will always be that there is an association between whatever your two variables are, so that variables are dependent. So again, in this case, I'm going to say between area and preferred spend. The second step then is just to state the significance level. So in this case, we're doing testing at a 1% significance level. Step 3 is to put the row and the column totals. Now this might have already been done for you in the question, but if it's not, then you need to add this in. I'm just going to add it to the table at the top. So the totals for each column first are 372, 279, 228, 141. And the row totals are 480, 540, and that means that the overall total is 1020. The third step then is we need to work out the expected frequencies. So all the values in the table are what we call observed frequencies. So these are O, and we're going to draw up a table that contains both O and E. So E are the expected values, and you can see from your list that E then, we work it out by doing the row total times by the column total and divided by the grand total. And you need to do this for each of the observed frequencies. So my observed frequencies then, I've got 156, 216, 144, so I'm just copying these from the table, 135, 120, 108, 60 and 81. So for the 156 then, you can see it's in this row and column, so we're going to do 372 times by 480 divided by the grand total of 120, and this gives us an answer of 157.06. Now I've done all my answers to 5 significant figures here. You must make sure that if you want your final answer to be 3 sig fig, you're working to at least 4. If the question wants the final answer to 1 decimal place, you must be making sure that you're working to at least 2 decimal places. So you need to work out these all the way down. So again, for example, the 216, we can see it's here. So we need to do 372 times by 540 and divided by 120. This time this gives us 196.94. So I'm going to work these out all the way down. So that's all the expected frequencies completed. Now the third column that we need in our table is for each of these values we need to do the observed value, take away the expected value, all squared, divided by the expected value. And again, you need to work this out for each of these in the table. So for example, the first one, the observed value is 156. Take away the expected value, which is 175.06, and then that needs to be squared and divided by 175.06. And again, here make sure that you are recording your answers to enough significant figures. So work that out on my calculator, I get 2.075. Second one again, it's a bit of an example. You would do 216 take away 196.94 all squared divided by 196.94, and this gives you 1.845. So you'd work these out all the way down. So once we've got all these values, the next step in our working it out is to total them. So we need to find the sum of this final column. So it's the sum of O minus E all squared divided by E. And this is our test statistic. So this is our chi-squared test statistic. So if you total all of those, then you end up with 10.237. So this is the test statistic. So the next step then is to use the chi-squared tables to find out what we're testing this against. So the first thing we need to do for that is we need to find what the degrees of freedom are. So to work out the degrees of freedom, which is V, then we're going to do the number of rows take away 1 and the number of columns take away 1, and we're going to multiply these together. So we've got 2. If I work that out, that's going to give me 3. So from this then, I need to find the value of chi-squared from the tables. So if you go to the chi-squared tables, look like this, we need to look up the significance level that we want, and we need to look up the degrees of freedom. So in this case, if we're testing at a 1% significance level, we need to look up 0.99, which is here at the top. And we've got degrees of freedom 3, so we go down to where 3 is. If I go across and find where these cross, I get 11.345. This is going to be my chi-squared value. Okay, so I need to write that onto my information. We now need to compare our two values. You'll probably find it easier to do it on a diagram. So I do a sketch of the chi-squared distribution. So I've got then that my chi-squared value from the table was 11.345, and this gives me my critical region. So if it appears in this critical region, then I'm going to reject H0. And if it doesn't appear in the critical region, then I'm going to accept H0. So I need to put on my test statistic, which is 10.2, which would be around here somewhere. So 10.237. And we can then clearly see that we are going to accept H0 as it's in that region. So we then need to come to our conclusion. So our conclusion is that we are going to accept H0 at a 1% significance level. The evidence then suggests that the area that people live in is independent of how they want the money spent. So the evidence suggests that the area people live in is independent of how they wanted the money spent. You must make sure that your final conclusion is in the context of the original question.